Welcome to OCULA from the Foundry. My name is John, and this is an introduction to some of the new features in OCULA 3. OCULA 3 is a significant upgrade that increases the ease of use and accuracy in all OCULA operations. It also adds several key features: a new disparity engine delivering cleaner, more accurate disparity vectors, new stereo retiming using stereo motion vectors, and new focus matching to fix misfocused cameras. It also adds a host of workflow tweaks and improvements, so here's some examples to show you. The solver node has been rewritten to increase the accuracy and ease of use in setting up your OCULA trees. If I add a new keyframe to this shot, you'll see that there's a new feature matching algorithm that delivers more accurate feature matches across the image without tweaking any matching parameters. There's also an alignment preview, if I hit P here, so this previews the alignment data delivered downstream so you can tell how good your solve is. You can tweak an error threshold to pick out the worst case matches and delete them straight away with the backspace key. You can also use that alignment preview to see how well your keyed alignment data works for other frames. So let's look at this frame, and we'll see the alignment doesn't work, so I need to add a new key to the shot. The cameras are changing. So those are the improvements in the solver node. The disparity generator node has been rewritten as well to deliver cleaner and more accurate disparity vectors, and this is crucial to getting great results in stereo 3D compositing. If we have a look at the disparity generated in OCULA 3, I'll switch to the horizontal component, you can see nice, clean, smooth disparity vectors. If you compare that to OCULA 2.2, you'll see lots of noise in these regions that are hard to match, and that requires cleanup before you can use it, and any cleanup reduces the accuracy of those vectors. So OCULA 3 delivers great vectors first time. We've also cleaned up and simplified the parameters, so it's more intuitive to set up and use. There's also a new ignore and foreground mask here, so that you can pick out disparity layers and separate the elements in your shot. OCULA 3 adds stereo retiming. There's a new vector generator node that calculates stereo motion vectors, and a retimer that uses them to slow down or speed up stereo footage. The key thing here is that if you retimed left and right views separately, you can break alignment and destroy the stereo 3D view. The vector generator node in OCULA calculates left and right motion vectors at the same time, making sure that your retimes maintain the stereo alignment. So if we look at our input footage, we're going to look at a 2.3 speedup generated using the OCULA 3 retimer. So here's that speedup. And the vector generator calculates vectors using the same algorithm as the disparity generator node in OCULA 3, so you get the same intuitive parameters to tune. It also has the same masks to separate out and calculate motion for different elements in the shot. OCULA 3 has a new focus matcher node that allows you to sharpen out of focus images. There's a kernel input so you can specify the aperture for deblurring. You can also use one view to rebuild the focus of another. So here we have a left and a right view, where the right view is out of focus. We're going to use the left to rebuild the focus of the right using the focus matcher node in OCULA 3. So here's the rebuilt right view, and we can compare that to the original input views. OCULA 3 adds a new occlusion detector plugin to create mattes for the occluded or the revealed areas between the left and the right view. It marks the regions where the views do not match and you can't rebuild one view from another. So I'm going to switch to showing the occlusion mask that's been calculated as a matte overlay. So these are the regions that are marked as different between the left and right view. And you can control how it calculates those occlusion masks. So I can turn up the depth discontinuities or how different it expects the images to be between left and right view. You can use this as a QC tool to tell where image building with new view is likely to fail, and it's also used by Color Matcher and the new Focus Matcher tools to define the regions where particular attention needs to be paid to the image content being pulled between left and right view. Color matching has been improved in OCULA 3. Here's a tricky shot with a large shift in colour between the left and right view. There's also some subtle changes in the reflections on the water. The Color Matcher node has been updated to include a new 3D LUT method, and you can export that LUT to use outside OCULA with the vector field node in Nuke. So you can create a rough colour match with OCULA. Here's the 3D LUT correction. and you can use that rough correction outside OCULA with a vector field node to get going with your comp whilst you wait for the full correction to be completed. Here's a full local correction on that image, and if I can compare the left and right views now, you'll see that all those reflections are reproduced on the left eye. So that's a great result. The colour matcher node in OCULA has been improved to have a new occlusion compensation method. So this pulls in the occlusion mask from the new occlusion detector node, and you can control how those occluded regions are colour matched between the views. Vertical alignment has been improved in OCULA 3 as well. Now all the transform methods concatenate, so you can use vertical skew to correct keystoning with a converged camera rig, along with all the other methods in a single filter hit. So here I've used a scale to take out focal length differences, a rigid rotation, and a skew to take out keystoning. And we're going to use that to correct the original images here, which have got a vertical offset happening. And here's the corrected plates. So now the offset is horizontal only between the views. Now that gives you a global correction, and you can export that as a corner pin for use outside OCULA. But the vertical aligner now has a new local alignment method that does a per pixel rebuild for the vertical mismatch between the views. And it does that based on the disparity that OCULA is calculating. So if we have a look at the disparity vectors for this shot, let's look at the vertical component, you'll see that that changes across the image. There's a change in the alignment with depth. And if you do a per pixel rebuild, you can compensate for different alignments with depth. So here we do the local vertical alignment correction, and we can switch between the left and right eye, and you can see that the offset is now horizontal. OCULA 3 adds new ways to review disparity. If we look at the disparity field that OCULA is calculating, this is showing an image of the disparity vector, so the disparity per pixel. But instead of looking at an image, we can also look at a disparity histogram in the disparity viewer node, and this gives an overview of the parallax in the scene, and we can check that against any parallax limits for violations. There's also a violation view in the disparity viewer that gives an overlay of where those limits are being broken, so we can bring that in and review the image. Now if I switch back to the histogram, you can also use that to see if there's any reconvergence happening in your node tree. So here I've got a reconverged node, and I can switch between the original disparity for the shot and a new disparity after that converged node, and you can see the shift in the scene. Finally, OCULA 3 gives you a handy stereo review gizmo to examine and review your stereo footage. So here's a shot we were looking at for vertical alignment and colour correction. And here are the corrected plates, and we're going to look at them with our review gizmo. So let's switch to the gizmo. You can see it's got a few tools to help you out. There's a checkerboard key mix, a difference tool, and a reveal tool. So the checkerboard key mix is showing the two views interleaved in a checkerboard. We can move a converge point to examine different parts of the image, and this is showing how well the two images line up in the alignment and how well the colour matches in the colour correction. So that looks pretty good. You can also view that with the difference tool. So if I switch to the difference, we can see minor differences where it's converged. And you can use the reveal tool to peep through from one image to the other. So they look well aligned and well colour matched. So that's just a quick overview of the new features coming out in OCULA 3, built on 3 years of industrial collaboration and artist feedback in stereo 3D VFX compositing.